Alright, so today we'll talk about polynomials, linear factors, the zero product property, and zeros. Um, if you've gotten to this point, you probably know what all of these are. You're just not real comfortable with the vocabulary. So we'll start off with what is the factored form of, and I'll give you an example here. So let's say we had the polynomial expression 2x to the third plus 10x squared plus 12x. Okay? With this particular polynomial, this is factorable. Notice they all have a 2 in common, 2, 10, and 12 in the coefficients, numbers out in front. And they all have an x in common. You've got x to the third, x squared, and x. So the greatest common factor for this polynomial is a 2 and an x. So if you take out a 2 and an x, you get x squared plus 5x plus 6. Then the second part of this is you can factor that quadratic x squared plus 5x plus 6. And so what that happens there is plus plus, there's lots of ways to factor these. Plus plus is a plus plus on the inside. X squared, the factors of that are x and x. Now the factors of 6 are 3 and 1, how about 6 and 1 or 3 and 2? And so we want to make 5 where it's both plus plus, so it'd be 3 and 2. And you could double check that. That's 3x and 2x, that's 5x, so that works. So that's kind of the quick method. I mean, my students hopefully have got a pretty good handle on factoring by now. So hopefully that's just a quick review. Now, what I have this written as, when it's factored like that, is it's a set of linear factors. So when it says to write something in a set of linear factors, don't be scared. It's just saying to factor it. And here is your set of linear factors. Okay? So there's one example. So we could do one more just for good measure. So let me just pop one more up here. And again, what I instruct you to do is go ahead and try it. Stop the video, give it a shot, and then start the video. Because once I get to save kind of time here, I'm going to go ahead and just keep going. But here's your example. So stop it, see if you can factor this, put this in a set of linear factors for me, and here we go. So the first thing you've got is a greatest common factor of negative 3x. So if you take out a negative 3x, I don't like the negative out in front. That's why I took it out. You might not have taken it out. You'd be just fine if you didn't. But I'm going to take it out, so that changes that to an x squared. Then a negative 6x, and then a plus 27 divided by 3 is 9, and the x's cancel. And so you'd have negative 3x, and then minus plus is a minus minus. X squared breaks into x and x. 9 breaks into 3 and 3, or 9 and 1, but I want to make 6. And so there you have it. And so this one would simplify just a little further as x minus 3 occurs twice. So we could say its multiplicity is 2. So there's your linear factor, your polynomial written as a set of linear factors. And the root here, this x minus 3, because it's squared, has a multiplicity of 2. And we're going to talk about multiplicity here in a moment. This one, all of these factors have a multiplicity of 1 because they're all to the first power. And we'll get into multiplicity shortly. Okay? So there's factoring and putting things in linear factors. Okay? Example 2, and it doesn't quite fit, and I apologize for that. Should have probably tested that first. Is how to find the zeros of a polynomial function. So now let's say instead of an expression, you've got a function. So let's just have something that's already factored. So that's x plus 1 x minus 1 times x minus 3. So let's say we had this function. Okay, it is already written as a set of linear factors. It's already in factored form for us. So we're going to use this zero product property to find the roots or the zeros of this. I use the word roots and zeros interchangeably. In this case, they're also the x-intercepts when we graph this. So all three of those really words could be used interchangeably. And so what we'd have here, x plus 1, x minus 1, x minus 3, well, we want to know what the x-intercepts are, so we're going to let y equal 0. And now use the zero product, it's a mouthful, the zero product property, and solve this thing. So essentially all that's saying, the zero product property is just saying, hey, you know, either this is 0, or this is 0, or this is 0, to make a 0 over here. Because anything times 0 is 0. So any one of those three could be 0. So all we do is just set them to 0 and solve them. That's it. Excuse me, should have put a 0 there. So here, if you were to solve this, you'd subtract 1. And so you'd have x equals negative 1. There's one of your zeros. Here you'd add 1 to both sides. And so x is equal to positive 1. And then over here, you'd add 3 to both sides. And x equals positive 3. Those are your three roots. Those are your three zeros. Those are your three x-intercepts. Now, let me pause for just 1 second. So to give you an idea of the x-intercept quality of this, so here in the input I have entered that function, that polynomial, and so I'll go ahead and hit enter so you can see that. And notice, I'll kind of adjust this a little bit here so that you can kind of see most of it, the max and the min. So there it is on the left, the function, and here it is graphically. Notice your x-intercept. So if I intersect my two objects, the x-axis and my function, notice there are my three x-intercepts, negative 1, 1, and 3, which are the zeros or the roots. That is where the function becomes 0. So I think it's good to see that. So that's that example. So let's try one more of those. Again, I would like you to give it a shot on your own. So here we go. Let me write it up here for you. So let's say we had y equals 9x to the third plus 6x squared minus 3x. So give that a shot. Go ahead and see if you can find the zeros of that function. Okay, so pause it, now begin. So the first thing again, we set that function to 0, so you'd have 9x cubed plus 6x squared minus 3x. You would then factor out your greatest common factor, which in our case would be 3x. So we'll pull the 3x out, which would leave us with 3x squared plus 2x minus 1. Sometimes that minus 1 is tricky for people, and that's okay. But that's how that factors. So then 3x is good. This 3x squared plus 2x minus 1, well, that factors to plus minus. Now, in the front, you'd have 3x and x. And in the back, you have 1 and 1, and it's plus minus. Now, you double check that to see if you did it, if you factored it right. Now, I intentionally kind of, through the numbers in helter-skelter there, I put the 3x squared and the x out front and the 1 and the 1 in, but I didn't necessarily pay attention to my signs, just to show you what could happen. So if you checked that, that would be 1x and negative 3x. Well, that's negative 2x. We need a positive 2x for that to factor correctly. And make sure you're double checking. Don't just throw numbers in and hope that it's correct. And so that should be a minus 1. That should be a plus 1. Now you check it. You've got negative 1x and 3x, which is 2x, and that works for your middle two and your outside two. You could FOIL the whole thing, but that's just a quick little trick in factoring. And so there's your linear factors. You've got 3x could be 0, 3x minus 1 could be 0, and x plus 1 could be 0. So here you would divide by 3 on both sides, and x is 0. Here you would add 1, then you have 3x equals 1, then you divide by 3, and so x equals 1/3. And then the final one, you'd have x equals -1. So there's your three zeros in your zero product. Okay, and I'll go ahead and graph that just to show you that on the x-intercepts. So again, I stuck it in the input here for GeoGebra, hit enter, and here again, notice it crosses the x-axis in 3 places. So I'll intersect 2 objects again. I'll click on my x-axis, click on my function, and B, notice you got 0, 0, you got -1, 0, and you got 0.330. Well, 0.33, I've got it set on the rounding, you know, just to the hundredths place. It would actually be 0.3 repeating. And so there it shows you your 3 zeros, or your x-intercepts. And so that is it. Now notice the multiplicity of each of those was 1. So now it moves us to the third example, and I try to keep my videos under 15 minutes. So that we're running out of time. But I do want to show this one last example. And that's kind of going the opposite direction. So let's say we want to find a polynomial function from its zeros. So let's say I gave you maybe 5, -6, and 7 were the zeros of this polynomial function. That's where it crossed the x-intercept, or the x-axis. So we know by, since those are zeros, by that linear factor model, we know the function would look like this. X minus 5, x plus 6, and x minus 7. So that is the polynomial. Now to find your polynomial, then, if you want to, you know, have it in more of a standard form with x to the 3rd power and on down, you would have y equals, and then you'd FOIL your first two. Well, I'm going to do this just quickly. I'm just going to FOIL these two. That'd be x squared plus x minus 30. I'm just saving time, times x minus 7. I would actually do more work than that normally, but I already kind of know that off the top of my head. And then I would FOIL the x minus 7 through both, which would be x to the 3rd. I'll spend a little more time on this one. Plus x squared minus 30x minus 7x squared minus 7x plus 210. And so here you'd have your function. Just after you combine a couple things, you'd have x to the 3rd minus 6x squared minus 37x plus 210, and you've got your polynomial function. And I'll graph that really quickly. Well, actually, I don't need to graph that. That's your polynomial function. All of those have a multiplicity of 1, because nothing would be much different. So let's say you had x equals 0, x equals -2, and x equals 1. Go ahead and give that a shot. So your function would look like this. Y equals x minus 0 times x plus 2 times x minus 1. And then you'd FOIL that again. X minus 0, well, that's just x. And then you can go ahead and distribute. I used FOIL, apologize. We're going to distribute that. FOIL is kind of a bad word to use because it doesn't always work. And so that'd be x squared minus x plus 2x minus 2. And then distribute that through, the x through, so you'd have x to the 3rd minus x squared plus 2x squared minus 2x. And here's your function. You could combine those last two terms, plus x squared minus 2x, and you've got your function.